Hello everyone, we have the last oxide of nitrogen at our hand, which is nitrogen 4 oxide NO2. It is the most important and unique oxide of nitrogen. Now why is it unique? It is neither a colorless nor an odorless gas. What is the color of nitrogen 4 oxide? Nitrogen 4 oxide is red brown in color, and the smell of nitrogen 4 oxide is it is a pungent choking smell. So if you inhale a lot of nitrogen 4 oxide, it can lead to choking, and it is a very poisonous gas. So you should be, when preparing nitrogen 4 oxide, you should take care you prepare it in a fume chamber to prevent poisoning. Also, nitrogen 4 oxide is an acidic gas. Okay, it is not neutral. So if a gas or if a substance is acidic, how do we establish that it is acidic? It changes moist blue litmus paper to red. Okay, so we have the physical properties of nitrogen 4 oxide. Just to introduce the gas here: red brown gas, it has a pungent choking smell, denser than air. So nitrogen 4 oxide being denser than air, what does it tell you? It is collected by downward delivery. The method of gas collection is downward delivery or upward displacement of air. Okay, now nitrogen 4 oxide is soluble in water. It is highly soluble in water. What does that tell us? That the gas cannot be collected over water method, right? So it can only be collected by downward delivery. It cannot be collected by over water method. Now when nitrogen 4 oxide dissolves in water, it forms two acids, nitric 3 acid and nitric 5 acid, HNO2 and HNO3 respectively. Okay, so it is an acidic gas, it is a poisonous gas. Okay, this is our reaction. When nitrogen 4 oxide reacts with water, it forms HNO3 plus HNO2. Aqueous, nitric 5 acid HNO3 and nitric 3 acid HNO2. Now nitrogen 4 oxide does not burn, neither does it support combustion. It is a strong oxidizing agent, the way we saw in nitrogen 1 oxide and nitrogen 2 oxide. Even nitrogen 4 oxide is an oxidizing agent, only that it's a stronger oxidizing agent. The nitrogen and oxygen bonds can again be broken down, similar to the way we saw in nitrogen 1 oxide and nitrogen 2 oxide. So magnesium can react with nitrogen 2 oxide. The reaction being highly exothermic produces a lot of heat energy. The lot of heat energy can break down the NO2 into nitrogen and oxygen. Magnesium combines with oxygen to form magnesium oxide, and nitrogen is given as the by gas. Okay, so what will be the observation here? The solid burns with a bright white flame, because magnesium burns with a bright white flame, and a white solid of magnesium oxide is formed. Now we have already covered these examples in nitrogen 1 oxide, but just to repeat, copper burns with nitrogen, copper reacts with nitrogen 4 oxide to form copper 2 oxide and nitrogen. What's the observation here? Copper is, as we know, copper is brown, right? Copper is brown, but it changes to copper 2 oxide, which is black. So brown solid changes to black. Okay, phosphorus can be, white fumes of phosphorus 5 oxide are produced. Phosphorus also reacts with NO2 to form phosphorus 5 oxide and nitrogen. Now, since nitrogen 4 oxide is an acidic gas, it reacts with alkalis to form two salts and water. What do we mean by that? What is an alkali? An alkali is a soluble strong base. Okay, like potassium hydroxide and sodium hydroxide. So nitrogen 4 oxide being acidic can react with either sodium hydroxide or potassium hydroxide, forming two salts and water. Now when sodium hydroxide reacts with nitrogen 4 oxide, we have sodium nitrate, sodium nitrite and water. These are the two salts that are formed: sodium nitrate, sodium nitrite and water. Okay, this is what happens when nitrogen 4 oxide reacts with an alkali such as sodium hydroxide. We can have potassium instead of sodium here to give potassium hydroxide. We can have potassium hydroxide instead of sodium hydroxide. So this will be potassium hydroxide plus NO2 to form potassium nitrate, potassium nitrite plus water. Okay. Now the thermal dissociation of nitrogen 4 oxide. Nitrogen 4 oxide is a gas, right? So it can be cooled and it can be further heated to decompose the gas. When cooled to 0 degrees, the nitrogen 4 oxide will liquefy to form a yellow liquid, the yellow liquid of N2O4. Now from the formula N2O4, what is the name of this compound here? N2 is dinitrogen, and O4, 4 is tetraoxide. Dinitrogen tetraoxide, which is a yellow liquid. Now when heated, the yellow liquid changes to the brown gas, which is nitrogen 4 oxide itself. On further heating, nitrogen 4 oxide decomposes to nitrogen 2 oxide and oxygen, which are colorless gases. So the reversible, the arrows here will show that the reaction is reversible. Okay. Now the uses of nitrogen 4 oxide. There are quite a number of uses, but we just need to know one or two. So what is the first use, and the most obvious use? It is used in the manufacture of nitric 5 acid. Also, it is used in the manufacture of explosives and plastics such as nylon. And the third use, oxidizing agent in lead chamber during manufacture of sulfuric 6 acid. So we will get into that deeper when we cover sulfur and its compounds, but for now these are the uses of nitrogen 4 oxide. Now there are two ways of preparing nitrogen 4 oxide, laboratory preparation. There is first, you react copper turnings with concentrated nitric 5 acid. Concentrated nitric 5 acid, conc for concentrated, which is about 65 to 67% nitric 5 acid. Okay, and copper turnings, our nice good all good friends, copper turnings. So copper reacts with HNO3, right? Now in nitrogen 2 oxide, we say to prepare nitrogen 2 oxide, we need copper turnings and dilute nitric 5 acid. The only thing that changes when preparing nitrogen 4 oxide and nitrogen 2 oxide in the first method is, instead of using dilute nitric 5 acid, we use concentrated nitric 5 acid. So that there is no production of nitrogen 2 oxide, you go directly to the production of nitrogen 4 oxide. So copper reacts with HNO3 to form copper nitrate, nitrogen 4 oxide and water. Copper nitrate is written like this: copper into brackets nitrate into brackets 2, because copper is valency 2 and nitrate is valency 1. When you cross the 2, you get copper 2 nitrate plus NO2 plus water. Equation is balanced with 4, 2 and 2. Now if needed dry, we know the three drying agents that are mostly used in our learning, which is anhydrous calcium chloride, calcium oxide and concentrated sulfuric 6 acid. Now we said nitrogen 4 oxide is an acidic gas, right? So it cannot be dried by a base. Now among the three drying agents that I just mentioned, which one of them is a base? Calcium oxide. So an important question they can ask you is, first of all, let's read this. If needed dry, pass the gas through concentrated H2SO4 in a wash bottle or anhydrous calcium chloride in a U-tube. Why is calcium oxide not used? The simple explanation is nitrogen 4 oxide, being an acidic gas, will react with calcium oxide. Instead of calcium oxide drying the gas, it will react with the gas. That is the simple explanation. So we still have to cover thermal decomposition of, I think, lead 2 nitrate, and we are done with nitrogen 4 oxide. So let's take a 2 minutes recess and we continue. So our second method of preparation of nitrogen 4 oxide is by heating lead 2 nitrate or by thermally decomposing lead 2 nitrate. So this is our setup here. You are thermally decomposing or you are heating lead 2 nitrate. What is the overall equation for the reaction? Lead 2 nitrate will decompose to give you lead 2 oxide and two gases, a red brown gas and a colorless gas. I'm sure you know the brown gas is nitrogen 4 oxide. And what is the colorless gas? The colorless gas is oxygen. Okay. Now let's make things simple. As you can see, there is a gas X here, collected by over water method. Now can we all guess which gas X is? I'll give you a couple of seconds. Okay, now the equation for the reaction tells you the two gases are produced, nitrogen 4 oxide and oxygen. Which gas is collected by over water method? Of course it is oxygen. Why? Because it is slightly soluble in water. There is no way it will be nitrogen 4 oxide, because nitrogen 4 oxide being soluble, highly soluble, it dissolves to form an acidic solution of nitric 3 acid and nitric 5 acid in water. So, which gas are we left with? We are left with nitrogen 4 oxide. How is nitrogen 4 oxide collected? Now, remember we converted nitrogen 4 oxide by condensing it into a yellow liquid of dinitrogen tetraoxide. This is exactly now what is used to collect the nitrogen 4 oxide in this setup specifically. So the nitrogen 4 oxide, 2 moles of nitrogen 4 oxide condensed to form 1 mole of nitrogen tetraoxide. We all know this is a brown gas and this is a yellow liquid. Fine. So when lead 2 nitrate is heated, arrows always represent heat. So when lead 2 nitrate is heated, it will give you lead 2 oxide left. The residue here will be lead 2 oxide, PbO. Let's go residue. Nitrogen 4 oxide is produced. How is nitrogen 4 oxide collected? As we can see, there is a freezing mixture here outside the YouTube manometer. This is a YouTube manometer. This thing here is a YouTube manometer. Outside it, in the wash bath, there is a freezing mixture. We can say ice cold water. So the nitrogen 4 oxide, NO2 will condense to form reversible, to form dinitrogen tetraoxide. And so what is the yellow, the liquid, the substance marked in red here? It is dinitrogen tetraoxide. This is how nitrogen 4 oxide is collected in this setup, by dinitrogen tetraoxide, which is then heated. After you have collected it in this YouTube manometer, you then heat it to give you nitrogen 4 oxide, the red brown gas. So it is collected as the yellow liquid, but then to separate it from the oxygen, which is brought down and collected by over water method. Now what are the observations in this setup? The first observation is where we started. We started with gas X. So what is the observation in this beehive shelf? Effervescence of a colorless gas, bubbles of a colorless gas, and the gas is oxygen. That's our first observation. Effervescence of colorless gas. What is the second observation? The nitrogen 4 oxide is produced here by heating the lead 2 nitrate, right? So there are brown fumes. There are brown fumes in this test tube. So brown fumes in flask or test tubes. Brown fumes of NO2 right here. Another observation is when the lead 2 nitrate is heated, produce lead 2 oxide. Lead 2 oxide, when hot, it is brown, orangish brown, but we can say brown. And when cold, lead 2 oxide is yellow. So a third observation is on heating lead 2 nitrate, there is a brown solid of hot lead 2 oxide, which then changes into cold yellow lead 2 oxide. So yellow and hot, yellow and cold, yellow and cold, and brown and hot, right? So this is the setup used for preparation of nitrogen gas, apart from the reacting copper turnings with concentrated nitric 5 acid. So that's it for nitrogen 4 oxide. Thank you for watching. Stay tuned.